Hi all. Hi all. In this video, I am going to explain how to start a Vivado and perform the VHDL experiments. So I will also cover all the steps to be followed while doing the experiment in the laboratory. And I will take an example of an AND gate and I will show you how to get the results, how to save the results, and how to take the printouts of the results so that it will be helpful for you when you are going for the laboratories. Please follow this video carefully, make a note of every point and do the experiments accordingly. So before going to start the Vivado, first of all, as an example, here I am taking an AND gate. So on the screen you can see before starting of any programming in VHDL, the first and foremost things what we should be taking is the schematic diagram, truth table, and the equation, output equation. Here you can see, you can follow the cursor. So here you can see the schematic diagram of the AND gate with the two inputs A and B and the output Y. So this is the truth table of the AND gate and this is the output equation of this AND gate. So before starting off any VHDL coding, you must be ready with all these three things, that is circuit diagram, truth table, and output equation. So after you are ready with these three things, then the first type of modeling is the data flow model. So here you can see the data flow model. In this VHDL programming, we'll be writing an entity where we'll be declaring the input and output ports, and then we'll be writing the architecture. Just follow this line. So in this you can see that the data flow model just contains the equation whatever we mentioned above. The equation whatever we mentioned above, the output equation y is equal to a and b, that is only written in this architecture. So after this architecture, begin will be there, and the equation whatever we mentioned for this logic circuit, y is equal to a and b, here just we are assigning y is assigned with a and b, and this implies a is ended with b and it is assigned to y. So in this way the programming of the VHDL can be done uh, using the data flow modeling. The same example I will try to explain. The same example I will try to explain in the Vivado software. So now you can see after installing the Vivado in your systems, you can get this icon. So double click on this icon, and in our labs we are having Vivado 2016.2, which is a server based version. So double click on the proper Vivado icon and wait for the system to respond. So don't keep on clicking the icon. Click once and wait for the system to respond. Once the system is responding, you will get the screen as shown in the figure. So whenever you are double clicking on the Vivado, you will be getting the screen like this. And here you can see in the quick start, you are having a link to create a project. So I request all the students to make a note of the points carefully by watching these videos so that you will be getting the benefit of not wasting the time in the lab. So click on the create new project, then a create new Vivado project wizard will appear. Click on the next, and here my suggestion is for this project location, create a folder with your registration number in a drive other than the C drive. For example, create a folder with your registration number in the D drive and save the location like that. So for example, I am selecting, I created a folder in D drive, and the name what I gave here is demo programs. So that demo VHDL programs. So I am selecting on that and I am clicking on select, and you can observe here. So the project location is D drive demo VHDL programs, and the convention what we used to follow is, instead of giving the project one, I will be giving a specific name, because it will be easier for us to open the projects later on. So here I am trying to simulate the VHDL for the AND gate. That is why I am giving the project name as logic gates, and then click on the next, then click on this RTL project, next, then create file, click on, and whenever you are clicking this create file, make sure that the target language is VHDL and the simulator language is mixed. Then click on create file, file type, you select VHDL, and the file name is the gate what you are trying to do. So here I am trying to give the name as and underscore gate. So a point to be noted here is, you should not use the keywords as the file name. Suppose if you are trying to give and, it will not accept. So don't give the keywords as the file name. That is why I am giving here and underscore gate. And one more important thing is, you should not give the space, and space gate you should not give. That is why I mentioned and underscore gate. You can give and gate without a space, or if you want to give the space, you must give the underscore. So by giving this name, I am clicking on OK and going for next. uh, Add constraints, we will not add any constraints as of now. Next, and we'll be getting the default parts window, and here in our lab we are following this criteria as of now, and this may change depending upon the availability of the FPGA kits. So as of now we are going with the category all, family Arctic 7, packages CSG 324, speed -1, and temperature. Here in this 2024 version, it is all. In our 2016, temperature range is -C, and we will not get any static power in the 2016. So once you are selecting these categories, select 324-1 as the default path and click on next. So you will be getting the summary of all what you selected, and click on finish. So then the new project will be created. So once the project is being created, another window will be popped up as shown in the figure, as shown in the video. So here the entity name, whatever you gave the entity name, it is appearing here. And now I am trying to write a data flow. That is why I am changing the name of the architecture as data flow. And here uh, in this port name, I am trying to give the inputs as A and B, and Y as an output, and Y as an output. So Y, and I will be making it as out, and click on OK. So after clicking on OK, you can see that in the sources window, under the design sources, you will be getting a .vhd file. So double click on that, then the workspace will be opened where you will be writing the code. And you can observe here, you are getting all the ports with inputs and outputs, and architecture with the name what you specified, that is the data flow. And after that architecture, you are having the begin. And here I am trying to explain the data flow model. As I told you in the beginning of this video, data flow model is just assigning the inputs to the output according to our output equation. So here for the AND gate, the output Y is assigned with A and B semicolon. So this is the simple equation and this is the data flow model for the AND gate. And in this video, I am trying to explain how to see the outputs and how to take the printouts of that in our observation and records. So after typing this, y is assigned with A and B, save this, Control S. After saving this, if you are having any errors in the later programs, because this is a simple program, we will not get any errors. Later programs like adders, subtractors, multipliers, decoders, if you are getting any error, the only indication is that instead of getting this VHDL file under design sources, you will be getting that in the bottom of these things. Means you will be getting the simulation sources, under that you will be getting these files attached. That is the only indication. And one more thing is, you can see the red lines in here wherever the line, whenever there is an error in the line. So here it is a simple code, there is no error. So after saving this, you go to this project manager window, and you can see here a run simulation link is there. Click on the run simulation, and then click on the run behavioral simulation. So once you are clicking on the run behavioral simulation, the simulation will be running, and you will be getting the waveform window. So after clicking on the run simulation, it will take some little time, and you will be getting the output window. You can see here, you can observe the cursor. So this is the output window where the waveforms are visible. So once the waveforms are coming, you can observe that A and B are inputs, Y is the output. And next step is how to give the inputs. So you see the cursor here, go to the A, right click, force clock, binary, leading edge value is 1, trailing edge value is 0, cancel after 2000 nanoseconds, and the time period for the A is 100. Click on OK. So the input for A is given. Similar process, right click on B, force clock, radix is binary, leading edge is 1, trailing edge is 0, cancel after 2000 nanoseconds, and here you should change the time period to 150. This is because if you are maintaining the same time period as 100 as of the A, then whenever A is high, B also will be high. Whenever A is low, B also will be low, so that you will not get all the combinations. With that in view, I am changing the time period so that we will be getting all the combinations of ones and zeros. Click on OK. So once after giving the inputs to A and B, then you can see here, there is a button for run all. Click on run all, and here you can see that the outputs has the color of the output window has been changed. Initially you cannot see these outputs. For seeing these outputs, you can click on this zoom in zoom fit. So zoom fit, if you are clicking on that, so you'll be getting all the outputs. Just float this, means this window you can make it as docking and undocking, or you can float it so that you can expand this window so that the printout will be clearly visible in the observation and record. And then properly you can zoom it here. Here the yellow line is called as a cursor. You just move the cursor to all the points and verify. See here, the first case 0 0, output is 0, 1 0 0, 0 1 0, and 1 1 is 1. So I verified all the logic for AND gate. So this is the proper output for the AND gate. Now what we are doing is just click on the print screen. So the print screen window will appear. Copy this part, Control C, and open the paint. This is what we are following in our lab. Open the paint app, paste the copied version here, Control V, and you can see here all the waveforms, whatever you got for this AND gate is pasted here. So whatever the things we require, select that, select up to this part and click on crop, so that you will be getting only that particular part. And my observation is that whenever you are taking the printout like this, we are not getting the proper color combination. As we are taking the black and white printout, I suggest to right click on that and go for invert color, so that white background will be appearing and the colors will be different for the waveforms, and whenever you are taking the black and white printout, it will be clearly visible. So this is the first waveform that we are going to get in all the experiments. So this is the procedure. Next, coming to the Vivado. So what is the next step we should do is, see here, first we are going for run simulation, we are getting the waveforms. Then the RTL analysis, click on open elaborated design, click on OK. Then automatically another netlist will be prepared and the RTL schematic will be getting. So in the meantime, what I will be doing is, I will just save this, save as JPG, and I am trying to save this as, I am trying to save this on my desktop with a name and get wave. So in the desktop, just I am saving it. You can save it in your folder itself. For an example, I am storing like this. So after clicking after this, you are getting the RTL schematic which is shown in the screen. So here this is the RTL schematic of the AND gate and this is the second output. So again do the same procedure, print screen and cut this part, cut this part, Control C, copy it, go to the paint, Control N means new paint window you are opening and paste it. So after pasting this, you can remove the unnecessary parts, and here don't invert the color, no need of inverting the color. And file, save as JPG. The desktop, I am just saving it as RTL for AND gate underscore AND gate. So this is the second output. You should take it from the Vivado. Then after that, just scroll it down and you can see the synthesis. Click on run synthesis. So then the synthesis will be running, and after that the synthesis will be running, we will be getting a synthesis report. So you can see here running the synthesis design. Just wait for a while. And in our laboratory, the Vivado is a server based. It will take a little bit more time, whatever you are watching now, compared to this. So because of the server based system, will be the time will be little bit more compared to what you are seeing in the video. So after clicking on that synthesis report, let it finish, let it finish. And after finishing that, you will be getting a synthesis report. So after getting this synthesis report, so you can observe here synthesis complete, and you click on open synthesizer design and click OK. And then you will be getting a synthesized report. So on the screen you can see here, this is the synthesis report. Just make this screen bigger, drag it, and again go for the snipping tool, print screen, and go for this snipping tool, go for the snipping tool and copy the part whatever we require, copy the part whatever we require, and then paste it again in the a new paint and crop the unnecessary things and save this as. And I think here we can again go for the inversion of the color invert. This will be looking like a clear layout. So save this as file, save as jpg synthesis report syn underscore and get. So these are the three outputs what we are taking till now. And then after getting these outputs, I have saved all the outputs on the desktop. Open a Word file. Open a Word file. Go to Insert Pictures from this device. And I have saved this in the desktop. So I am going to the location where I saved my outputs, desktop. And first you click on the waveform. So a waveform will be pasted here. Then follow the same steps for the other two pictures. This device, go for the RTL schematic, insert. So you can crop the unnecessary area of this NAND gate. Just go to the picture format, click on the crop. So whatever is needed, you just keep that part and the remaining things you can crop. So crop this, and so this is the second. Then go for the third picture, that is the synthesis report. This device, and click on the synthesis report and click on the insert. And even here you can remove the unnecessary parts. You can crop. So after cropping this, you can observe that all the three waveforms, whatever is required, are pasted in a single page. Take this as a printout, and whatever the modeling we are doing, the outputs will be same and the procedure will be same. And in the next video, I will try to explain the structural modeling of a full ladder with examples. And whenever you are performing, make a note of these, students. Whenever you are doing the different modelings, the only things that will be changed is this RTL schematic. Suppose for this AND gate, if you are doing for the behavioral modeling, then this RTL schematic will be changed. The remaining things will be same. So what I suggest you is, whenever you are doing the experiments, the waveforms will be same and the synthesis report will be same. Only this part, the RTL schematic, will be different. So whenever you are performing the experiments with the three modelings, try to paste the three RTL schematics, so that suppose for the full ladder, we'll be getting one RTL schematic for the full ladder data flow, one RTL schematic for the full ladder behavioral, and one RTL schematic for the full ladder structural. So three RTL schematics will be pasted, and this waveform and this synthesis report will be saved. And this I will be explaining in the next video. Carefully follow the steps and uh, get ready for the lab properly. Thank you all.